Welcome to UR Tech Partner, your ultimate destination for mastering AI and DevOps. Dive into the world of cutting-edge technology with us and unlock the secrets of artificial intelligence and development operations. Stay ahead of the curve and elevate your tech skills. Learn AI and DevOps with us today.
Okay, hello everyone. Today we are going to discuss the Kubernetes here. Kubernetes is a very important concept in the DevOps, and I would say that it is the most important stuff in this whole series, which essentially means that we are going to discuss some stuff here that why it is important, what problem does it solve, how does it solve, and what is the architecture. What is Kubernetes and what problem it solves and how it solves that problem and this architecture of Kubernetes, right? So these are the topic we are going to discuss right now, which are kind of very important topics. So okay, well, we have seen that there are different technologies around to manage the containers. Why we need containers? We have discussed this in depth. That why when somebody write a code, then this code has to go through from the test and trial and the unit test, integration test, and a lot of tests, and not tests, but the test. So yeah, and after that. This code is deployed somewhere, and for the deployment you need a Dockerization environment, which is very efficient. Why we need it? We have in description below a lot of series of videos which you can see that why we need to Dockerize, what efficiency it gives, how virtualization work, and all those stuffs. Right, great. So yeah, then we have seen that Docker Swarm is an option when you need to manage a lot of containers. When you manage a lot of containers, definitely you need something. Swarm is the one technology which is actually try to manage and automatically master and client-based architecture where it push on your container automatically, replicas, auto scaling, auto port mapping, and these stuff it does. But when you will see the architecture of the Kubernetes, it is more fascinating. And let me tell you that more than 80% of organization in this IT world using Kubernetes. And why they use Kubernetes, you will know it when I let you know the architecture and all this stuff, how it does it work and how fascinating it is, how beautiful this tool is, and why that come up with the revolution and why industries totally now shift on that tool and why industries actually has so much confidence and how why industries love that tool. So this is what we discuss. Definitely, the overall architecture of Kubernetes is very fascinating. How does it work? So let me just describe you the history and where does it come. So almost 15 years ago, like 2 decades ago, Google was a little bit worried about its internal microservices because that was on Docker and Docker and Swarm. These things are very good, but Google decided to build his own complete tool for that purpose, which means that they come up with the idea that we write everything, we create an architecture which is built on the containerization runtime technology. Containerization technology is there in the market for the decades. It's very good, it's fascinating, it's beautiful. But the thing is that they thought that well, and they have built everything on the top, which is really great. So what it does is that they built whole stuff on the 15 years. So 15 years long, 15 years long, they have built something. So then they make it open source. Why they make it open source? Because more people come into the market, they use it as open source product, they implement it, and over the best of time, it's going to be more fascinating and implemented. So that was the reason behind to make that. Okay. So, well, right now, this is open source technology. The beautiful thing is that underlying Containerization technology is agnostic, and Kubernetes don't care about you use Docker, you use LX, that you use containerd, you use whatever. So yeah, which means that the containerization and virtualization technology you can use any in the market, but the benefit it will still give you. Okay, and you see that how beautiful Google services are. Like there is a very less number of outages in the Google services. Why? Due to this beautiful tool. So let us draw something. So for drawing something, we need three main blocks. Number first block is actually the user interface block, right? And second block we need is the cube master block, and maybe third block we need is that mm, the client-based node architecture. And well, to just make it like a little more bigger and bigger, uh, make them little bigger here. I don't know if that much bigger is enough or not, but yeah. Yeah, these are the three main, let's say like that, overall blocks of uh, main blocks of architecture. Now if you understand the architecture of Kubernetes, this means that you have understood the 50% of Kubernetes because it is very complex and sometimes, it is very difficult tool to understand. But once you understand how actually things work, then it is very easy, let's say like that, or let's say like that, you understood the intrinsic way of communication of the module, which means that it is very easy and intuitive for you to understand. So let's see what's that. So that is kind of, that is nothing but this is user interface or UI. UI is the place where you interact with the services. UI is the client. UI is the space where you start interacting with your stuff. And UI has two paths. First, you can also interact all services with help of kubectl, which is command line tool, or for other plugins and integration or OpenShift or whatever third-party tools, which offers you a user interface, and this offers you a user interface as well. You can also interact with the user interface as well. Okay, so which means that you can do this actually. Mm, okay. Is there any option to? Why I'm not able to draw outline? It's really weird. Yes. Because it is, okay. This is line. Okay, this is UI. And you can say that if these services are interact with help of so with help of something called block. The second block, very important, is cube master. The third interface is client or node. right? There could be one node, there could be a two nodes, or there could be a multiple nodes running, right? Now it is clear that we have major three components. First component is the user interface or the interface where from your commands are going. Second interface is kube master, something which handle your command and do its management and pass on your request, whatever. And the third is that that works or workers or multiple workers, where actually performs the stuff. So up to that, this is very easy, no problem. Now let's see that what elements we got in Kube Master. Kube Master has API server. Kube Master has API server. Let's do this blue and blue. All the user interface are blue. Master is yellow, and everything here in node is the green, right? Your master is yellow. This is again blue and API server. Now API servers has very important role here, and we'll see what this role is. But this has very important roles actually, because how Google has designed the Kubernetes is that they have a communication structure. They have built one module called API server. API server does nothing. It is single point of communication, which means that any component within any module cannot communicate with each other without API server. What API server does, API server actually sends all the information to subsequent component to do some stuff. We'll discuss which those steps are. No, I didn't want that. So for example, this is component number one. API server always talk with control manager. Let's make this control manager a little bigger. Control manager. Control manager then is responsible for checking that is everything is running as requested or not, which essentially means that there is another component, queue scheduler. Now we'll discuss everything in detail, that how they work, what they work for, and how they communicate, and what does they do. And then there is a small component again here called etcd. etcd. Now what happened is, so let's take a scenario. You're sitting here, right? You're sitting here, you need to pass on your request here. This request either could come from UI or command line, regardless, whatever it is. You want to say that, okay, please create a container for me and run my application on it. For example, this is your goal. You send the command from kubectl. Kubectl is nothing but interface where you input your command, or graphic browser based interface where you say something or give command. This is the user end. This request goes through the communication module to the API server. Now it is API server which really sends command to the control manager and ask him that this is what user want to do. What user want to do? User want to create a, okay, imagine that this is a arrow. Why on earth? Okay. API server asks control manager that a user want to create an instance or a new container to run some application. Control manager asks etcd. What is etcd? Etcd is nothing but a database which actually store all the information regarding the current state of everything, request, namespace, whatever it is regarding Kubernetes. It's trying to save everything here. Why does it save? They have database key value pair structure. It is nothing but simple database. What does that database? That database simply trying to see the current state. And any change in the state actually get stored in this database whenever any new update, new state, any change, whatever happened within the whole cluster. Whatever happened within the whole cluster, the state information and everything gets stored in etcd. Etcd is nothing but simple database. Now there is one component, control manager. Control manager, as suggested from the control manager name, that it is controlling everything, that please create something, delete something, create container. If there is no container available, make it available. That's what it's work. This is the manager in the restaurant, which thinks that okay, on which table is free, in which table we need to get payment, on which table we need to do something in the restaurant. Definitely manager does that, right? And this is the job of manager to make sure that whatever requested by the user here is someone who orders the food on the restaurant, and whatever order by food or whatever order by the user is get fulfilled and fulfill what he needs. That is the purpose of this control manager. Well, now there is one another thing which is also, very important, which is kube schedule. And what does this kube schedule do is that, for example, you have different kind of resources, right? You have 10 computer running, you have 5 computer running, and there is different needs. For example, you have 50 GB RAM somewhere different CPU. Scheduler is only responsible to get the IP address resources and store them to etcd to make sure that where it is quite feasible to deploy new resources, where it is the most optimal to provide the resources requested by the user so that there is a balance in the load. For example, we have 5 computer and it is nothing optimal if I run everything on the same computer because it will get overly loaded and 4 other computers just sitting idle and doing nothing, right? That's why we need some scheduler. So that is the task of this scheduler actually to make it sure. And yeah, that's how it works. And let me shortly explain that how they communicate with each other. Okay, we have the another component, and this component has some stuff to do. Let us see what it is doing. So, for example, every single node, client or node, let's say like that, this is node number one. Let's say like that. This is node one, and yeah, this is node one here. And on this node, you have something running. You have something running. You need some software, of course. This is nothing but a simple computer. The node is nothing but a simple computer or the virtual machine, right? And you need to install something here as well. And what component you need to install? You need to install, let's say like the kubelet. Kubelet. You need to install a kubelet. Well, sure. I will explain shortly what does kubelet do. And second, we need to install a kube proxy. This is also a very important concept that we need to install kube proxy here. And these are the two software or the component of the Kubernetes which does something very important, and I will tell you what they does for you. So, so this is the kind of architecture on the worker side. This is the kube master. Kube master communicate with the clients. Client is nothing but a simple computer or the virtual machine. On the virtual machine, you have installed kubelet, one software. What it does, I will shortly tell you. Kube proxy, what it does, I shortly tell you. So they make sure that whatever asked by the user, they make it possible with help of containers. This is nothing but a container. This is nothing but a containers built with the help of container runtime engine. Container runtime engine, or otherwise we can call it right now for simplicity a Docker. Any container runtime engine could be here. As I said that it could be LXD, containerd, whatever technology. There are many like 5 to 7 major containerization technologies similar to Docker available in the market, but you can use any one of them. So well, using now there is one software here, Kubelet. The purpose of Kubelet, it's making sure that what containerization technology available within this stack, for example, if it is Docker, it asks Docker to please create a container for me, use that custom image by the user and put the application code inside, and please uh, create a container for me. When Docker respond him, okay, I have created a container for you, then it's create a pod. Like what is pod? Pod is nothing but a name of pod is nothing but a name of container in the Kubernetes. In the Kubernetes world, we name container as a pod. So this is nothing but this is a pod one. This is nothing but this is a pod number one. One. This is nothing but pod number two. Pod pod two. And what does lives inside the pods? You can do right. So what right the okay. Yeah, that's a secret thing. Yeah, that's how this works. So very simple. kubectl put a request to the API server, and API server says that, for example, kubectl user says that please give me two container to run my application. Now the work of a control manager is to check that in ECTDDC, check in the cluster in the node 1 and node 2. These are the worker node 1 or worker node 2. Is there containers or pods available as requested or not? Then ECCD tell back to control manager that there is no pod available, although nothing is available on cluster already. Then API manager asks the scheduler, please tell me the name of the node or name of the computer where it is more efficient and where the mostly resources are free to create. Then it's go here, it's things because it has a record of everything, and then it thinks that it is very efficient right now to create a new pod on node number 1. It tells back to the API server that okay, I think so that it is very good to create a new pod on the node number 1, and then it says okay, great, and ask the control manager to save this information. that I'm going to create a new pod on the node number one, this one. It saves the information in etcd, and then API server actually says to kubelet. Kubelet is the underlying technology, or let's say like that, it is a kind of service which is responsible for creating a new container and pod. What it does, it automatically, with the help of CRI, container runtime engine, which is Docker, create a new pod, assign the IP to the pod, and whatever number of container you need, it's create them, deploy whatever image you want inside it, and then very beautifully it's create a pods. And regularly it checks the status of the pods and the container. Now, pod, it is the responsibility of the pod that it checks all the time that container one and container two must exist in this pod and how they are required. In the similar fashion, they must exist here. And now you will be wondering that what is the purpose of this kube proxy then? The purpose of kube proxy is to make networking happen between these nodes and these master and everything. Because the kube proxy is something which use third-party networking tools. We have seen in the Docker Swarm, we use bridge and overlay network. Bridge is nothing but which communicate with two switch of the internet so that they make communication across the different network segments. And if the network segments is the one segment, within that one segment, all the nodes can communicate directly because kind of they are interact or connected to the cable directly. But if these networks are not directly connected with the cable, which means you need some firewall or you need some internet service provider or the router routing table to route them. So that's how that works. And kubeproxy is nothing but it makes all the networking possible within the cluster. So that's the role of the kubeproxy, which gives you networking. So here scenario is very simple right now. Right now, what it is, let's take a example of a restaurant. Restaurant, new customer comes here. New customer says, I need food. This, for example, this is some software. Here is software where you say that, okay, I need software. On the Kase, somebody enter that on somewhere somebody asked for the food biryani. It instantly gives this request to the manager of the hotel or the restaurant. Okay, some customer need food. It says ask to the kitchen, for example, here how much food we are available and if this food is possible or not. It says that no, this food is not prepared yet, and we are starting this to prepare. It asks another employer, which is scheduler, do you need which table is would be efficient to let them sit and which table is available and where there is less rush, and scheduler go visit and tell that I think so table number 3 and table number 4 is empty and we can ask our customer to sit there. Okay, then it knows that table number 3 would need to be provided on the table number 3, and then this is updated in the database with the control manager and API server. This is like a manager or the main control unit says that, well, I will ask the chef to prepare the food. It connect here kubelet, who is the person who knows how to make biryani or special food. And then, for example, he's going there in the special department. Let's say like that, we have special worker. For the Thai food, there are Thai team. There's for the Indian food, there is an Indian team. On the Indian team, it says that, do you know that, and it's using the technology or the whatever method of cooking, for example, a steam roast or the grill, whatever. It asks it to please provide that food, prepare it. And the person is saying, well, I have prepared the food and I place it here, please pick it up. And then it goes back and says in the database that your food is prepared. When it get that, it gives the notice to here and it sends the notice your food is prepared. Similar fashion, this is how the architecture works. You get the request, please contain a container, please create a container. This request goes to API server talks to control manager. Does that services already exist or not? It's replied back. If not, it does ask the scheduler to recommend me which node is more efficient and says node number one. It goes node number one and say this infrastructure here to kubelet to please create a pod. With help of Docker, it's trying to create a pod, one to whatever is requested, and to let them communicate with each other to make this application happen. This kube proxy actually make every networking happen. And that's how your overall structure of your Kubernetes works. Now it is also very important that how they do networking. This is another topic. This is a very complex topic because under the hood, actually, they create a virtual network, and this virtual network assign the IP to the pod, and this IP is kind of static, which means that whatever happens to a container, it's get destroyed or blown out, no matter what is the IP of container, we don't care about, because that's why they have the layer on the top of container. Why? Because this container could be killed, they're ephemeral or destroyable or vanishable or whatever data inside get deleted, but the IP and everything remains same. We don't care about the IP of the Docker, we care about the IP of the pod, and this IP of the pod is connected to the IP of this node, and with the help of this IP of the node, you can communicate here, and then automatically Kubernetes knows that if the valid request come through deep node number one IP, then it should able to communicate all other nodes if some container or something is some ports sitting here. For example, some component of application are getting dragged or getting pulled from the port number two in the node number two. And if I give the IP address of the node number one and port number, this port mapping automatically maps together and gives you final result on the browser. So this is very important concept. The networking is also very important, but that is not much important in the with the context. If you need to create as a infrastructure manager to this engine, otherwise this much concept is very much necessary, and we'll then now see how we can create a complete cluster. For the sake of simplicity, we can see that this whole okay, this whole okay, this is filled. Let's not fill it. This whole block is nothing but a Kubernetes cluster. This whole block is nothing but a Kubernetes cluster. Great. This whole block is nothing but a complete Kubernetes cluster. And that's how this cluster works together to make everything possible. Thank you very much. Stay tuned, and I will come up with the practical hand-ons later on. Bye.